Have you ever pondered what happens when matter gets swallowed by a black hole? Let's embark on an interstellar journey to understand these cosmic enigmas. Black holes, aptly named for their complete absorption of light, are regions where space-time is so intense that nothing can escape their gravitational pull. Yes, not even light, the fastest thing in our known universe. These celestial wonders are born from the remnants of massive stars. Imagine a star, much larger than our sun, reaching the end of its life cycle. It explodes in a spectacular supernova, leaving behind a core. If this core is sufficiently massive, it collapses under its own weight, warping space-time around it and forming what we call a black hole. These invisible entities are like the universe's most efficient vacuum cleaners, drawing in anything that dares to venture too close. So next time you gaze at the night sky, remember, in essence, black holes are the ultimate cosmic vacuum cleaners, sucking in everything that ventures too close. So, what exactly is inside a black hole? Well, let's dive right in. A black hole, in all its enigmatic glory, comprises three main components: the outer event horizon, the inner event horizon, and the singularity. Imagine the event horizon as an invisible boundary, a point of no return. Anything that crosses this cosmic line, whether it's a stray star or a beam of light, gets irretrievably sucked into the black hole. The outer and inner event horizons are essentially this boundary's outer and inner layers. Now let's venture deeper into the heart of the black hole, the singularity. This is where all the magic happens. It's the core of the black hole, where its entire mass is densely packed into an infinitely small point. Here, the laws of physics as we understand them break down, and time and space cease to exist. Thus, a journey into a black hole is a one-way trip to a place where space and time lose their usual meanings. What are some of the fascinating theories and discoveries about black holes, you may wonder? One remarkable concept is Hawking radiation. This groundbreaking theory proposed by physicist Stephen Hawking suggests that black holes aren't the eternal prisons they were once thought to be. Instead, they can slowly lose energy, shrink, and ultimately vanish. Imagine that. But the intrigue doesn't stop there. Black holes also have the extraordinary ability to warp space-time, leading to phenomena like time dilation. This means that time near a black hole moves slower than time further away. Picture a cosmic vortex, slowing down time as you approach its heart. Studying these celestial enigmas could potentially unlock secrets of the universe and the nature of gravity itself. The more we unravel about black holes, the closer we inch towards understanding the fabric of our reality. Black holes, therefore, are not just cosmic vacuums, but keys to understanding the fundamental laws of the universe.